So there's a genetic control of what's happening in the brain of people. And other genes can affect it as well in the cortic nucleus. So that's one change that we see in ADHD, which is that the brain is not working as effectively to inhibit when it should be inhibiting. There's a different kind of change. This is the response to reward. And in this kind of test, what the children have to do is they have to press a series of letters come up on the screen. If it's an X or an O, you have to press the button. In one condition, you just know whether you got it right or not. In the other condition, you know and you win a penny every time you get it right. So it's a rewarded system. So what we're visualizing is the difference between those and the difference that a reward makes. And what we're finding then is that it's really quite a specific change, because the people with ADHD, we compare both with control children, but also with people who don't have ADHD but do have what they call conduct disorder, which means the oppositional kind of problem, like the first boy I was showing in the picture of the three boys, who are antisocial, who are aggressive, but who don't have the disorganization that goes with ADHD. And then what we find is there are specificities in it, because these frontal areas are indeed reduced activation in ADHD compared even with children who have other forms of behavior problem. But if you look at the effect to reward, then it's a different story, because then it's the children with conduct disorder who are the ones who are activating less. So it's like there's one route into problems, which is the ADHD route of disorganization and failure to inhibit problems. And there's another route, which is the more